Adeshola Afolabi is a data scientist that I met this year in PyCon Namibia. Unluckily, he couldn't get his visa to come here to Spain, but still we wanted to give the talk anyway, so he's going to give it remotely. Thank you very much, Adeshola, for volunteering to still do this. And that's it. All yours. Please thank our speaker.
Thank you, Joalu. I'm happy to be doing this. Hi, everyone. My name is Adeshola Afolabi. I'm from Lagos, Nigeria. And I'll be giving a talk on simple A/B tests for precise advertising in Nigeria. Okay, so to start, I will be talking about the advertising space, the challenges, the description of users, the value proposition, the good products, bad products, and we'll be doing some experimentations on two machine learning models. But before I dive in, so this is me. So I'm a blend of these three things. I work for Terragon Group as a machine learning engineer. I also consult for a data consultancy firm. When I'm not working, I love to do sports. I'm an athlete. Unfortunately, I have a 100-meter record that wasn't recorded. That's sad. I'm a huge Barcelona fan, and I love to watch movies a lot. So yeah, this is me. Um, so diving in, I'll start by explaining what it's like in Nigeria. So most firms that have products, this general assumption, they're like, oh, we're a population of 200 million people. And if I'm able to sell my product to 1% of the population, I'll be fine. That's 2 million people, which is usually not the case. So the actual reality is we have half the population that just use internet. And out of this half, we have just 12% that are active mobile and social users. So that means every firm, we have approximately 50,000, is fighting for the 12%, that's 12 million people. So if you had to do the calculation, if you had to distribute the users to each of these firms, that's 240 users per firm. And this split across different sectors. We have the financial service institutions, we have the small and medium-sized enterprises, we have the fast-moving consumer goods and the telcos. So how do you want to, split these users? Imagine having just 240 users for your products. You're not going to make so much money. You're not going to scale. So basically, it gets funnier because you have this 12%, and not everyone is um, still using smartphone. We have people that use USSD, low-end devices. We have people that use Opera browsers, and you basically want to, reach the highest number of people. So that's another problem, but it also presents an opportunity. So you basically want to have high conversions when selling your products. You want to be part of the larger chunk that has this 12%. So what then do you do as a firm? So basically, when these firms come to us, they're like, you know what, guys, I have this product and I want to sell, but I would like to reach a whole lot of people. But it's crazy because these guys, we have some of them that have good products, we have some that have bad products. So basically, users with good products are, or firms with good products are the people that have the mass appeal. People want to use their products. What they basically want in this case is to scale up and keep their existing users. On the flip side, people with bad products don't care. They just want their products out there. So what we do is to help them sell regardless. So starting off with experiments, you want to let them know, okay, I'll start with a subset of people, and if it doesn't go so well, we could make recommendations. Either you have to change your application size, you have to change your landing page. It could be that it takes a lot of time to load, and so on. So we do a lot of experimentations to validate these things. So whether you have something good or you don't have something good, it's always a starting point. So I'll be talking about experimentations. So basically, it's like the baseline for starting out. The simplest case is a simple A/B test, a two-way test, and it basically means you want to validate what you know, or you want to disapprove something else. So it's basically what you already know, maybe something old, and your alternative idea, the new thing you want to do. Um, So the process is simple, quite simple. You're basically formulating your hypothesis, you are designing your experiments, and you are making inferences. So this process is applicable in many regards. It could be that you are comparing a landing page against the other. If I direct my users to this landing page, what happens? If I direct them to this other landing page, would it give me better conversion? Also, the ad creatives conveying the messages. Is the message clear enough? And yeah, what I'm going to talk about, which is the performance of machine learning models. So you have a new model that you want to test. You're saying if I deploy this new model, I'm going to have way more users as opposed to the old model. So basically, when you want to try to evaluate your machine learning models, there are two methods. You have the offline and the online. So the offline happens during the prototyping when you have like just evaluate with different evaluation metrics, your precision, your recall, your F1, and sometimes your hyperparameter tuning. And your online evaluation happens when you want to test on live data. So this is something I worked on. So I built two models, logistic regression and Keras. And for a particular campaign, logistic regression has always been used. But now I just built Keras, a model with Keras, and I want to see if I deploy this model, there will be responses. So by the way, the predictions here are just the propensity of the users to click on the ad. So user A has a 0.45%, meaning a user B has a higher propensity to click on the ad for the logistic regression model. On the flip side, for the Keras model, user A has a 0.51, user B has a 0.80. So basically, you could do everything. You could do your offline evaluation. You could do like all the necessary checks, but still your model doesn't perform well in live production. So you basically want to experiment on these things to see what works, and you can eventually roll out to the larger audience. So, but before I dive in, so let me review some concepts. First things first, what's an hypothesis? What's a treatment group? What's a control group? And what are your null and alternative hypotheses? So your hypothesis is basically the statistical method used to make decisions using experimental data. You're saying is the new version of the machine learning model better than the old one? Your treatment group is basically the new arm you're exposing your users to. So I'm going to use Keras for my treatment group. Let's see if it works better. The control group is basically what you used to know, your universe, the normal thing, what happens. So nothing changes. I keep using my logistic regression, nothing changes. So I'll expose the users to logistic regression. Your null and alternative hypotheses are basically your statements. You're saying there won't be any real difference if I deploy Keras. And the alternative hypothesis is saying no, there will be a difference if you deploy Keras because Keras is in fact a better model. So I'll be doing a demo using my Jupyter notebook. So I have it here. I don't know if it is clear, but I'll try to be as explanatory as possible. So starting off, I import some useful libraries. I have the stats model, I have pandas, I have SkyPy, and there's an exhaustive list of processes that you should do to ensure you're doing the right things. So it's very important to go through each one of these steps when you want to carry out an experiment. So first things first, you want to define your goal and hypothesis. So your goal is to determine what version of the model is better, right? So you're saying version A is the logistic regression model, which is previously used. Version B is the Keras model. So that's like your hypothesis. You either want to validate it or you want to disprove it. Next up is your treatment and control group. You want to basically split your traffic. So you want to expose some users to the logistic regression model. You want to expose some users to the Keras model. You also have to identify your key metrics. So for this demo, we'll be using click-through rate, also known as CTR. So I want to know how many users will click if I expose them to these models. Also, you want to identify data to collect or log. So you want to know what's important. Over time, from experience, it's always good to collect everything possible because you never know what comes in handy. But basically, you want to collect the user ID, you want to know the experiments the user saw and their responses as well. You also want to determine the effect size or minimum detectable difference. This means is how many people are sufficient enough to detect a change. So there's a bit of computation that goes into it. So the first thing is you have a baseline. You know that prior to now, when you use logistic regression, you typically get a 4% conversion. So 4% of people click on your ad. But now you're looking to move the 4% by 10%. So meaning, so if I have 100,000 users as a result of the 4% CTR, and I want to move it to, let's say, 150,000, this is just an example. How many percent do I need to move the CTR? So in this case, the assumption is let's move it to 4.4%. So an additional 10% to give me extra 50,000 users. So how many people is enough to detect that change? So that's where your effect size comes in. Also, you need to determine your fraction of visitors and the treatment and control. We will be using a 50-50 split. And you also want to do your power analysis. So this is where your tolerances come in. You want to avoid mistakes. So we have two tolerances. We have the false positive, we have the false negative. So your false positive is also alpha, saying you want to leave error for mistakes 5% of the time. So that's like the layman explanation, saying, okay, 5% of the time I'm allowed to make mistakes. But the other 95%, I'm confident that I wouldn't be detecting a difference when there isn't one. So that's basically my false positive. We don't want to detect a difference when there isn't one. That's expensive. You are going to make a huge mistake and you might end up losing more money. Also, for your false negative, you want to detect an effect when there's an effect. But if you're unable to detect it, then that's a false negative. So basically, power comes to play here. But before you get your power, it's usually 1 minus your beta. So in this case, we're using a 20%, meaning the error for margin in this, the margin for error rather is 20%. And your power is basically 1 minus beta, which is 80%, also 0.08. So to calculate your sample size, like I mentioned earlier on, all these things are important. So your P1 is the 4% CTR, which is 0.04. Your P2 is the extra 10% you need to get to. Your significance, your alpha is 0.05, your power is 0.8. And with this, you're able to get your sample size, meaning to detect a difference, you need to push to at least 39,454 users. But don't forget, we have the treatment arm and the control arm. So you have to multiply this value by 2. So in a nutshell, for it to determine your sample size, for it to detect the difference, you need to at least push to 78,908 users, going by these values here. So next up is to determine how long the experiment runs. So knowing fully well you need 78,908 users, you could divide your traffic into like 20,000 daily. And this will take about 4 days in this case. Next up is when the experiment is done, you need to aggregate your data. And just an extra check, you could run an AA test to ensure there are no biases. Yeah. So let's assume you're done and you need to analyze your results. So by the way, this is a synthetic data generated to match the requirements of this case. So it's not like it's real, but just to explain. So these are users, these are their IDs. This 0 means none of these users clicked on the ad. And the test group here is saying, okay, this guy belongs to the test group or it doesn't belong. So 0 means it is not in the test group, meaning the user is in the control group. 1 means the user is in the test group. Yeah, so that was like the explanation here. The user ID is the ID of the user. The click is whether the user clicked or not, and whether the user belongs to the test or control group. So this is like a distribution of the number of clicks for both test and control group. We have 37,000 people in the control group and 41,512 people in the test group. So you want to do your significance test. So because this is a two-way test, you rely heavily on your test statistic, provided the data is normal. So your test statistic is important when you're using a normal distribution. So these values tell you whether your experiment is significant enough or not. So your p-value is the probability of rejecting your null hypothesis when it is true. So a 0.05 p-value means a 5% risk of concluding that there's a difference when there's no difference. Your test statistic in this case means the size of the difference relative to the variation in your sample data. So the interpretation of these values vary, but typically when your p-value is way less than 0.05, by the way, your p-value is synonymous to your alpha, your type 1 error. So if you've put 0.05 as your alpha and your p-value is synonymous, so you want something less than your p-value, something significantly less than your p-value, to conclude that there is in fact a difference. So remember what I said, um your type 1 error is when you detect a difference where there isn't. So you don't want to make that mistake. So the error for margin is 5%. And when this is significantly lower than 0.05, which is 5%, then you can conclude your test case wins. Otherwise, you adopt your control case. So remember, our control is the logistic regression. Our test is the Keras model built. So from what I've said, this is significantly lower than 0.05. So we'll adopt the test group. So for the remaining of the campaign, after the 4 days, so if it's supposed to run for a month, we would ensure we push to users that we make predictions using the Keras model. So the Keras model wins in this case. The Keras model is the test case. Yeah. So when you're able to do this effectively, you ensure that there are no biases. You ensure that you're sending to the right number of people. You ensure that your tolerances are set right, and the inferences you make are going to help with the campaign in full. You're going to save some money. And remember, I said 12% of the users in Nigeria are the addressable audience. So when you're able to do these things the right way, you're able to have a larger chunk of that 12%. So that's what we've basically done for most of the firms that come to us. And there's been significant improvements in the number of users they've acquired over time. Thank you very much.
Thank you very much, Adeshola.
Yeah. So I would like to entertain questions. And
Excellent. So there's no time for questions, or maybe a very quick one. Okay, so, well, Adeshola, thank you very much again for the talk, and hopefully see you next year in PyCon Spain 2020. Okay?
all right, thank you very much.
Bye.
All right, bye.